Hello, and welcome to my demonstration and evaluation of my Impenta glove. Using 3 flex sensors to control a chord progression and the inbuilt OSC accelerometer to control the improvisation, this glove is designed to allow non-pianists and musicians of any age to improvise in an E minor pentatonic scale around a blues chord progression. The glove is a simple black work glove designed for flexibility and durability. There are 3 flex sensors upon the middle, ring and little finger, which are routed to the OSC analog inputs A0, A1 and A2 via an extension cable, which allows for the OSC board to be attached to the back of the glove. This is so the user can have full range of motion of their hand, whilst also being able to rotate the accelerometer. Wires and components are attached by blue tack, brass clips, and elastic bands. This isn't quite as slick as the Mimu glove, but it has a certain Iron Man Terminator feel when worn. When considering future endeavours, hiding the circuitry from the user will be important so that accidental wire unplugging will be minimised. However, for this assessment, being able to have full access to the glove components at all times proved efficient in the build phase and during demonstration. There is also a pitch scaler in the patch, which transposes incoming signal into a chosen tonic and mode. This allows for multiple types of improvisation, but only 3 chords are available. Being able to switch chords with another interface would have allowed for more musical experimentation from the user. The Max patch scales the input from the flex sensors rather than using an auto calibration, which arguably would have been more successful as the flex sensors are inaccurate and highly temperamental, meaning that adjustments to min-max ranges need to be made throughout use. This undermines the goal of the user not needing to use the mouse of the computer and reduces transparency. Additionally, this patch uses line tilde to smooth the incoming signals set to 400 milliseconds so as not to cause too much delay, but enough to stop jittering. The longer the delay, the more dependent I am on having good knowledge. Considering this, as the object of this interface is OO transparency, less latency is beneficial. A metaphor could be drawn between the glove and the playing of a piano, which is useful when considering this glove's purpose. A pioneer example in this field is the Mimu glove, which has vast capabilities. The Mimu glove has 8 flex sensors rather than our 3, can also recognise up to 9 postures through accelerometers, magnetometers and gyroscopes. This is a very developed interface which has inspired this project greatly. If we were to build a similar glove in the future, using more measurements of gestures would be incorporated so that even more user exploration can be involved. As we can see here, the rotation affects what note is being played. And the flexion of the finger affects which chord we're playing. However, this is inaccurate as these keep failing and changing.